The National Electrical Code, or NEC, mandates ground fault circuit interrupter, also known as GFCI, protection for all 125 volt, 15 amp and 20 amp receptacles located in residential bedrooms. This requirement applies regardless of whether the bedroom is situated in a dwelling unit or a guest room. The primary reason for this regulation is to enhance electrical safety and minimize the risk of electrical shock hazards. GFCI devices are designed to detect ground faults, which occur when electricity unintentionally flows to ground through an unintended path. This can happen if someone comes into contact with a live wire or a faulty appliance. When a ground fault is detected, the GFCI quickly trips the circuit, cutting off the power supply and preventing potentially fatal electrical shocks. The NEC mandate for GFCI protection in bedrooms recognizes the potential for electrical hazards in these spaces. Bedrooms often contain various electrical appliances such as lamps, televisions, computers, and phone chargers, which can pose a risk of ground faults if they are damaged or improperly used. Additionally, people may be more likely to be barefoot or in contact with grounded objects while in their bedrooms, increasing the risk of electrical shock. The specific NEC section that addresses GFCI protection in bedrooms is 210.8. This section outlines the general requirements for GFCI protection in dwelling units and other locations, including bedrooms. It specifies that all 125 volt through 250 volt receptacles installed in locations specified in 210.8 A through 210.8 F must have GFCI protection. In the case of bedrooms, the relevant portion of 210.8 is typically 210.8 A, which requires GFCI protection for receptacles installed in dwelling units. It is important to note that the NEC requirements for GFCI protection can vary depending on the specific edition of the code that is adopted by a particular jurisdiction. Local amendments or interpretations of the code may also affect the application of these requirements. Therefore, it is always advisable to consult with a qualified electrical inspector or licensed electrician to ensure compliance with the applicable codes and regulations in your area. The installation of GFCI protection in bedrooms typically involves replacing standard receptacles with GFCI receptacles or installing GFCI circuit breakers in the electrical panel. GFCI receptacles have a built-in sensor that detects ground faults and trips the circuit. GFCI circuit breakers provide similar protection but are installed in the electrical panel and protect the entire circuit. When selecting GFCI devices, it is important to choose products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or OL. This ensures that the devices have been tested and meet industry safety standards. In addition to the NEC requirements for GFCI protection, there may also be local or state regulations that require additional safety measures in bedrooms. For example, some jurisdictions may require arc fault circuit interrupter, also known as FSI, protection for circuits serving bedrooms. FSI devices are designed to detect arc faults, which are another type of electrical hazard that can cause fires. Arc faults occur when electricity jumps between two conductors, creating a spark or arc. This can happen if wiring is damaged or insulation is worn. While GFCI devices primarily protect against electrical shock hazards, FSI devices primarily protect against fire hazards. It is also important to note that the NEC requirements for GFCI protection apply to both new construction and remodel projects. When remodeling a bedroom, it is essential to ensure that all existing receptacles are brought up to code by installing GFCI protection where required. This may involve replacing existing receptacles with GFCI receptacles or installing GFCI circuit breakers in the electrical panel. In addition to the NEC requirements for GFCI protection, there are several other safety measures that can be taken to reduce the risk of electrical hazards in bedrooms. These include using surge protectors to protect electronic devices from voltage spikes, avoiding overloading electrical outlets, and regularly inspecting electrical cords and appliances for damage. It is also important to keep electrical cords away from water and to avoid running them under rugs or furniture, which can damage the insulation and create a fire hazard. Furthermore, it is essential to teach children about electrical safety and to keep electrical outlets covered when they are not in use. This can help to prevent accidental electrical shocks or burns. When working with electricity, it is always important to take precautions to protect yourself from electrical shock. This includes turning off the power at the circuit breaker before working on any electrical wiring or devices, using insulated tools, and wearing rubber gloves and safety glasses. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to do the job. In summary, the NEC requires GFCI protection for all 125 volt, 15 amp and 20 amp receptacles located in residential bedrooms. This requirement applies to both new construction and remodel projects. The primary reason for this regulation is to enhance electrical safety and minimize the risk of electrical shock hazards. GFCI devices are designed to detect ground faults and quickly trip the circuit, cutting off the power supply and preventing potentially fatal electrical shocks. When installing GFCI protection, it is important to choose products that are listed and labeled by a recognized testing laboratory and to comply with all applicable codes and regulations. In addition to the NEC requirements for GFCI protection, there are several other safety measures that can be taken to reduce the risk of electrical hazards in bedrooms, such as using surge protectors, avoiding overloading electrical outlets, and regularly inspecting electrical cords and appliances for damage. The NEC also covers other aspects of electrical installations in residential buildings, including wiring methods, grounding, and overcurrent protection. Understanding these requirements is crucial for ensuring the safety and reliability of electrical systems. For example, the NEC specifies the types of wiring that are permitted for different applications, as well as the methods for installing and supporting the wiring. It also provides requirements for grounding electrical systems to minimize the risk of electrical shock hazards. Grounding involves connecting the electrical system to the earth, providing a path for fault current to flow back to the source, which helps to trip the circuit breaker and to energize the circuit. Overcurrent protection is another important aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow, which can cause overheating and fires. The NEC specifies the size and type of overcurrent protective devices that are required for different circuits, based on the ampacity of the wiring and the load that the circuit is expected to carry. The NEC also addresses the installation of lighting fixtures and other electrical equipment in residential buildings. It provides requirements for the spacing of lighting fixtures, the type of wiring that is permitted for connecting the fixtures, and the grounding of the fixtures. It also addresses the installation of smoke detectors, which are required in all dwelling units to provide early warning of fires. In addition to the technical requirements for electrical installations, the NEC also includes administrative requirements that address the permitting, inspection, and enforcement of the code. These requirements vary depending on the jurisdiction, but they typically involve obtaining a permit before starting any electrical work, having the work inspected by a qualified electrical inspector, and complying with any corrective actions that are required by the inspector. It is important to note that the NEC is a living document that is updated every 3 years to reflect changes in technology and industry best practices. The latest edition of the NEC should always be consulted when designing or installing electrical systems. The NEC is developed by the National Fire Protection Association, or NFPA, a non-profit organization that is dedicated to reducing fire and other hazards. The NFPA brings together experts from various fields, including electrical engineers, contractors, inspectors, and manufacturers, to develop and update the NEC. The NEC is widely adopted by states and local jurisdictions throughout the United States, and it is also used as a model code in many other countries. In addition to the NEC, there are also other standards and codes that may apply to electrical installations in residential buildings. These include standards developed by organizations such as Underwriters Laboratories, the Institute of Electrical and Electronics Engineers, and the American National Standards Institute. These standards provide detailed requirements for specific types of electrical equipment and installations. Understanding the NEC and other applicable standards and codes is essential for ensuring the safety and reliability of electrical systems in residential buildings. By following these requirements, electrical contractors and homeowners can help to prevent electrical shocks, fires, and other hazards. It's important to emphasize the role of qualified electricians in ensuring electrical safety. Licensed electricians possess the knowledge, skills, and experience necessary to properly install and maintain electrical systems in accordance with the NEC and other applicable codes. They can identify potential hazards, perform electrical calculations, and select the appropriate wiring devices and overcurrent protection for different applications. Hiring a qualified electrician is particularly important for complex electrical projects such as wiring a new home or remodeling an existing one. Attempting to perform electrical work without the proper training and experience can be dangerous and may result in code violations. Furthermore, many jurisdictions require electrical work to be performed by licensed electricians. The NEC also addresses the installation of renewable energy systems, such as solar photovoltaic, also known as PV, systems and wind turbines. These systems are becoming increasingly popular as homeowners seek to reduce their reliance on fossil fuels and lower their energy costs. The NEC provides detailed requirements for the wiring, grounding, and overcurrent protection of renewable energy systems, as well as the interconnection of these systems to the utility grid. The installation of renewable energy systems requires specialized knowledge and skills, and it is important to hire a qualified contractor with experience in this area. The NEC also addresses the installation of electric vehicle, or EV, charging equipment in residential buildings. As electric vehicles become more common, the demand for EV charging stations is increasing. The NEC provides requirements for the wiring, grounding, and overcurrent protection of EV charging equipment, as well as the location and accessibility of the charging stations. The installation of EV charging equipment may require upgrades to the electrical service panel and wiring, and it is important to consult with a qualified electrician to determine the best approach. Furthermore, the NEC addresses the installation of swimming pools, spas, and hot tubs. These areas are particularly susceptible to electrical shock hazards due to the presence of water and grounded metal surfaces. The NEC provides detailed requirements for the wiring, grounding, and bonding of electrical equipment in and around swimming pools, spas, and hot tubs, as well as the installation of GFCI protection. These requirements are designed to minimize the risk of electrical shock and ensure the safety of swimmers and bathers. The NEC also covers the installation of fire alarm systems in residential buildings. Fire alarm systems are designed to detect fires and alert occupants, providing them with time to evacuate the building. The NEC provides requirements for the location, spacing, and interconnection of smoke detectors, as well as the wiring and power supply for the fire alarm system. In addition to the NEC, there are also other codes and standards that may apply to fire alarm systems, such as the National Fire Alarm and Signaling Code, also known as NFPA 72. It is important to consult with a qualified fire alarm contractor to ensure that the fire alarm system meets all applicable requirements. The NEC also addresses the installation of communication systems such as telephone, cable television, and data networks. These systems are becoming increasingly important in residential buildings as homeowners rely on them for communication, entertainment, and access to information. The NEC provides requirements for the wiring, grounding, and bonding of communication systems, as well as the separation of these systems from power wiring. The installation of communication systems may require specialized knowledge and skills, and it is important to hire a qualified contractor with experience in this area. Furthermore, the NEC addresses the installation of low-voltage lighting systems, such as landscape lighting and accent lighting. Low-voltage lighting systems operate at a lower voltage than standard 120-volt or 240-volt systems, which can make them safer and more energy efficient. The NEC provides requirements for the wiring, grounding, and overcurrent protection of low-voltage lighting systems, as well as the location and accessibility of the power supplies. The installation of low-voltage lighting systems may require specialized knowledge and skills, and it is important to hire a qualified contractor with experience in this area. Finally, the NEC addresses the installation of standby power systems, such as generators and battery backup systems. Standby power systems are designed to provide power to essential loads during a power outage, ensuring that critical equipment and appliances continue to operate. The NEC provides requirements for the wiring, grounding, and overcurrent protection of standby power systems, as well as the transfer switches that are used to switch between the utility power and the standby power source. The installation of standby power systems may require specialized knowledge and skills, and it is important to hire a qualified contractor with experience in this area.